These are the components used in this demonstration: 4 toy cars, 2 Raspberry Pis, camera, and LED traffic lights. The Raspberry Pis will be connected to a power source, and both of them will be connected to the computer monitor by 2 separate HDMI cables. The 2 Raspberry Pis are not physically connected to one another. They will, however, communicate through my local Wi-Fi router. We will be using port 8005 for this demonstration. I will be changing the settings of the computer monitor to switch from HDMI connection 1 to HDMI connection 2 and vice versa whenever I will want to demonstrate what each Raspberry Pi is displaying. The Raspberry Pi in this picture with the camera and LED traffic lights is to be considered the microcontroller of our project. The Raspberry Pi without anything attached to it is to be considered the server of our project. This demonstration will cover various scenarios which will be fully explained. For this first demonstration, I will show how our Raspberry Pi microcontroller is able to detect cars. I encourage the audience to look at the output which will be shown on the computer monitor. Whenever a car is detected, a rectangular box is placed around the car and a confidence level is displayed. Also, in the output section, a message is revealed indicating how many cars it has detected. Here we see that there are no cars in front of the camera. I'm going to run the program. As you can see, the output showing that there is no cars in front of the camera. This is also the live feed. Now we'll place the first car in front of the camera. We can see the camera has detected a car by showing a rectangular box around the car. The second car is placed in front of the camera. Similarly, we see another rectangular box is placed around the car. A third car is placed in front of the camera. Now there are 3 rectangular boxes and the output showing car, 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 indicating that there is 3 cars. A fourth car is placed in front of the camera. And once again, a rectangular box is placed around the car. Scenario 1. In this scenario, there will be no cars placed in front of the camera. I will demonstrate how both the microcontroller and server behave and communicate with one another for this situation. The cycle time of the traffic light for this and all the following demonstrations were chosen to be 30 seconds. This, however, can always be easily adjusted. Here are the 2 Raspberry Pis. The first one is the microcontroller and the second one is the server. I'm going to first start by running the server program. As you can see, sockets were created and sockets is awaiting messages from the microcontroller. Now I will go to the output of the microcontroller and start the program as well. I'm going to press run. And the light turns green. Now since the cycle time is 30 seconds, this green light will stay green for 15 seconds. Now it turns red. We see the output says that 15 seconds was the green time. We expect to see 15 seconds also for the red time. And this is exactly what we see. Now we also see that the number of cars was sent to the server. Now let's check back to see the output of the server. Here I'm switching the HDMI settings. Now this is the output of the server. There are no cars in front of the camera. This demonstration successfully shows how the 2 Raspberry Pis are communicating with one another and the right message was sent. Scenario 2. Now one car will be placed in front of the camera. Please note that for this and all further demonstrations in this video, we will assume that there is also a car present at the other side of the intersection. Here are the two Raspberry Pis. This one is the server. I will start by first initializing the program on the server Raspberry Pi. The socket is created and the socket is waiting for messages from the microcontroller. I am now going to place the car, for one car, in front of the camera. The camera is looking at the car. Now let's look at the microcontroller. This is the program of the microcontroller. Please pay attention to the output. I started the program and look, a car is detected and the green light is on. This message shows how long was the green light on. The light turned red. Now it also shows how long is the red light, and we see that the number of cars was sent to the server. Now let's check back with the server to see if the message was sent. Now we're switching to the server. As you can see, there is one car in front of the camera, so the message was received. Scenario 3. Now two cars will be placed in front of the camera. We start again by initializing the program on the server. The socket is created and the socket is awaiting messages from the microcontroller. I'm going to go ahead and place another car in front of the camera. Now there are two cars in front of the camera and the camera is directly looking at the cars. Now let's switch to the microcontroller. I am going to run this program. Please pay attention to the output. We see that two cars have been detected and the green light is on. This displays the duration of the green light. And this displays the duration of the red light. Now we see that the number of cars was sent to the server. Let's go back to the server now. Now we're in the server. And we see that there are two cars in front of the camera and the message was successfully received. Scenario 4. Now three cars will be placed in front of the camera. Here we have the two Raspberry Pis. I am going to first initialize the program on the server Raspberry Pi. The socket is created and the socket is awaiting messages from the microcontroller. Now I will place a car in front of the camera so that three cars are directly placed in front of the camera. Now let's switch to the microcontroller Raspberry Pi. I am going to now run the program, and please pay attention to the output. It says car, 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 therefore indicating that three cars have been detected. The green light is on. This indicates how long was the green time. And this indicates how long was the red time. Now we see that the number of cars was sent to the server. Let's check back with the server. The server is displaying that there are 3 cars in front of the camera, therefore showing that the server received the data successfully. Scenario 5. Now 4 cars will be placed in front of the camera. Once again, we have 2 Raspberry Pis, and now I am placing the car in front of the camera. I will go ahead and now run the program to initialize the server. The socket is created, and the socket is awaiting messages from the microcontroller. Now I will switch to the microcontroller. I will run this program, and please pay attention to the output. Car, 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 car. This indicates that 4 cars have been detected. The green light is on. And the light has turned red. This is the duration of the green time and the duration of the red time. Now the number of cars was sent to the server. Now let's check back with the server. And we see that the server is displaying that there is 4 cars in front of the camera, showing that the message was received. This is the end of our senior design demonstration.